Hello, my name is Cody McVicker, and today I'm going to be sharing with you a little bit of insight on the population of animals and global warming, specifically the polar bears in the Arctic. We're going to see how the increase in heat is affecting our wildlife. Now, global warming has been a problem dating back to over 450,000 years. Global warming has sprung up to be a highly dangerous problem for not only human life, but more so on wildlife. With the increase in temperature caused by global warming, many have gone blind to the problem regarding animals. This presentation will show how the population of wildlife has decreased with the increase in temperature and how it will continue to plummet if we stand by and ignore the situation. Now the thesis. How does global warming affect the population of animals? I hypothesize that with the rapid increase in temperature due to the human acts, it will decrease the population of our wildlife by a large amount. With the increase in temperature, habitats and foods are lost, and without those necessities, they will be lost forever. A little bit of history. Global warming has been a common problem for over 450,000 years, as stated before, but it wasn't really a huge problem until 1975, when temperatures began to rise at a more rapid rate. Earlier ideas of global warming stemmed off of the numerous glacials, commonly referred to as ice ages, and interglacials like the Holocene interglacial that we are experiencing today. Basically, with the melting of ice in the Arctic, we are seeing more flooding, more water being increased into the ocean, and less land mass for the animals that live on these ice glacials. Now, the increase in heat strongly affects glacial areas, as the increase in heat causes the weather conditions to be unsuitable to have the glacial landscape, and therefore removing food, shelter, and increasing the chances of flooding with the amount of ice being melted. The drastic increase in the emission of CO2 within the last 30 years caused by burning fossil fuels has been identified as a major reason for the change of temperature in the atmosphere. And almost 100% of the observed increase in temperature in the last 50 years has been mainly because of the greenhouse gases, like water vapor and CO2. Now, where is global warming going? Over 93% of the effects of global warming is affecting the ocean. The Arctic animals at most, who use the ocean to hunt or the ice to live, are largely affected by this. Polar bears in general are one of the Arctic animals that are seeing a large impact from global warming, which is the animal we're going to be focusing on mostly for our video today. Now, the extent of floating sea ice in the Arctic Ocean. Now, this is a graph that shows from 1980 at the start, over here, to 2010 over here. Now we can see with our line of best fit, which is the red line that strings from the top of the graph to the bottom, we can clearly see that there has been an increase in the Arctic ice. Over on our y-axis here, we have the millions of kilometers squared, which is covering the ice. So basically, it has started back in 1980, right up here, at about 7.8 million kilometers an hour, all covering ice. But we can see, as we reach around 2010, 2008, you see it has dropped to over 5.2 million kilometers an hour. The kilometers squared. Now that may not seem like much, but about a 2 to 3 million per kilometer squared decrease is a very large effect, and that's a lot of animals who are losing their homes and their shelter. Now this is a little chart which shows the polar bear population in regards to the floating sea ice in million kilometers squared. And we can see a few numbers here and how this number has slowly dropped from 7.93 million kilometers squared to 6.41 in a span of 2 decades. And we can see how the polar bear population has also decreased from 1,314 to 784, approximately, in this area. Now when we graph this, we can see it's not a very clean graph. It's kind of a weak correlation. There's not really kind of line that shows, but we can see with a little bit of a line of best fit, it kind of shows like an increasing thing, an increasing line. So when we look from the data from the sea ice and the polar bears, our line of best fit is fit by the equation 94.31x minus 42.86, with our r value being 0.14 and our r squared value being 0.02. Now these are very weak numbers, as the closer the r squared is to 1, it gets stronger, it shows a stronger relation, so it being closer to 0 shows very weak. Our r squared value being 0.02 shows that only 2% of our data is actually really affected from the sea ice. So, we need to look at here. Does this work? As stated before, the r and r squared values are very weak, and because of this, we need to look into other options as to maybe why this is working. So the next set of data will focus more on the CO2 emissions in the past 3 decades. So many factors add up onto the problem of global warming, mainly CO2. We can see from this chart that many of these activities cannot really be avoided. Transportation, industry, agriculture, forestry, and so on cannot be stopped, as many of these are a necessity to our life. What is the costing our wildlife? Here's data in the 1970s, showing from the year 1970 to 1980, approximately. And it shows our global CO2 emissions approximately throughout the year in millions, and our polar bear population. Now we can see here through 1970 to 1980, we can see kind of a gradual increase. This is kind of where the problem really started, and we see the decrease. And then as the increase goes on, so does the CO2 emissions. So it's not really a huge impact right there. We can see kind of the increase, and we see, it's not really affecting too much in the 1975s, as the problem was only new, and as polar bears weren't really affected at the time, because we can see from a sea extent graph, a lot of their land mass was still there, and it wasn't really much of a problem. And with a line of best fit, our line of best fit is y equals 823.80x minus 4,122.48, with an r value of 0.79 and an r squared value of 0.63. This basically shows that around 80, our number is closer to 1, so it's a stronger correlation, as our graph showed. It was more of a medium correlation. And with our r squared value, it shows around 63% of our data was the dependent variable. 63% of it was dependent on the independent variable. With a mean CO2 in these 10 years of about 6 parts per million, and with a mean bear population of about 846 in the span of 10 years. Now, when we look at the 1980s, we can see here there's a very large drop, a very large increase in the global emissions of about 1.1 parts per million, and then with the polar bear population dropping about 1,000 polar bears in these past 10 years. And we can really see the problem rising as global carbon emissions are growing, and we haven't really understood this yet. It was kind of more of a new idea, so to speak. So when you look at the graph, we can see a decreasing value here. The values, the line of best fit is in a decreasing form, and we can clearly see a drop in animal population. Now our y squared value, our line of best fit, is fit by the equation negative 567.64x plus 4,814.39, with an r value of negative 0.88525 and an r squared value of 0.78. What it shows here is again, we have a strong r value, which shows a strong data, and with around 80% of our data depending on the other form, on the other part of the data. So 80% of our dependent variable depends on the independent. And with a mean CO2 of 6.91 and a mean bear population of 893. And we can clearly see how the mean for the CO2 is increasing from the previous slide, from 0.83. But we can see the mean of the bear is a little higher here because of the first couple of points of data. But we can see, as we look into the next slide, the decrease in these numbers. See the numbers in the 1990s. These are low numbers. Nothing's passed over 1,000 like the first couple of years. And we can see the polar bear population is kind of struggling here. But it started to change here, started to fix up here. But we can see the really drastic change in the 1980s. Usually around 1985 to 1995. And we can see the global carbon emissions are still increasing. It's increased by a small amount, but it's still increasing. And we see the polar bear population continues to drop, and then it kind of stays at a steady point for a little while. Then it continues to grow again as we kind of learn how to deal with this problem. We can see from the chart here, it's a little bit of an increasing value. It started to decrease, and then it started to increase again, which is where we get this value from. It's kind of a medium, not really linear, but like kind of scattered correlation. No really correlation at all. With a line of best fit, which equals 516.09x minus 3,686.31, with an r value of 0.54 and an r squared value of 0.3. Now we can see the data in the 1990s. It's kind of a lesser effect because it's kind of it's a problem we've known for a bit now, and it's kind of starting to be fixed. So what it shows here with a 0.54, it's kind of a medium kind of strength to it. It's not really as strong as it was in the past couple of decades, but it's still stronger than the sea ice extent, the first data we analyzed. And with an r squared value of 0.3, it only shows that 30% of our dependent variable depended on the independent variable. And again, our mean of CO2 continues to rise from the 6 that was up before by about 1 part per million, and then we can see the mean of the bear has dropped by about 300, which does show that the bear population definitely has decreased. It's definitely taken a toll. Now we're going to look at the data as a whole throughout 1970 to 2000. Now we can see here it's kind of a weak negative linear correlation. It's not really strong. It's kind of got a linear point, but it's again, some argue it's linear, some it's not. You know, these got a few couple of points that are out there, but we'll focus a little bit on that later. Now when we look at this data, through using all the data from the points, we get the linear equation of that being negative 216.61x plus 2210.29 with an R value of negative 0.501, negative 51, and an R squared value of 0.25. Now this data is very weak. With an R squared value of only 25% of our data, depending on the independent, and kind of a weak kind of R value, 0.5 is not really close to 1, it's halfway there. And we can see, it's not really good. And then with our mean CO2, 6.94 parts per million, that's very large. It's still effective. And then the mean of the bear is only 707, which is, it's okay, but it's not great. But we can see here, if you look at the graph, we've got a couple of points over here and a couple of points over here, which aren't really part of the mesh of points over here. So we can count them off as outliers. So if we look over here, we can see our data without the outliers, and these are the outliers here that are shown, the 5 near the bottom and then 1 near the top. And then this is a graph without the outliers, a lot simpler, a lot cleaner, and there's no points up here, there's no large points out there, and we can kind of see the more linear part to the graph. Now, let's look at our data without the outliers. Our Y value is negative 4, our biolab best fit is negative 493.97x plus 4,270.41, with an R value of negative 0.89 and an R squared value of about 0.80. Now that's a big increase from last time. And the mean of the CO2 is about 7.14 parts per million, with the mean of the bear about 742. Now if we look at our next chart, we can compare the outlier versus not the outlier, and we can see the R value has significantly increased by about 0.40, which shows a very strong relation now compared to when we had these outliers. And with our R squared value, we can see a large increase there. 55% from 25 to 80 is a very large increase. Because as you can see, with the removal of outliers, the Y equation does change. That does change a little bit, but really what is the big difference is the R and R squared value. As removing the outliers really strengthens up the relation between the polar bears and the CO2 emissions, and shows a stronger relation and how it really does affect it. Now with our analysis, we can see this is a cause and effect relationship. While the CO2 increases, the population of the polar bears decreases, and that's what's shown in the graph before, and as it shows with a negative slope, we can clearly see that this is happening. Now, with an R squared value rounding about 0.8, we can assume that there was around an 80% chance, around 80% of our dependent variable, is being affected by global warming, which is a significantly high amount. It's very large compared to the data that we started with. Now, in conclusion, with the problem of global warming being a threat for over 450,000 years, there is no mistake that its presence has caused threats to human, plant, and animal life. But it was not until further investigation that we can really observe how much of an effect global warming really has. On allocation with the data shown, it is very clear that there was a significant increase in the population of animals in the Arctic regions during the 1970s to 2000. It was not until much later we were able to allocate the problem and start coming with a solution to continue to ensure that these species do not go extinct. A little more on the wrap-up of the topic. Now we can clearly see. Now I want to be able to prove my thesis. Now my thesis was, how does global warming affect the population of animals? And I hypothesized that the rapid increase in temperature due to human acts will decrease the population of our wildlife by a large amount, with the increase in temperature, habitats, and foods being lost. And without those necessities, they will be lost forever. And I believe, with the data that we have collected here, I believe that my thesis and hypothesis has been answered correctly. Definitely with the graph that we are shown here, there's a decrease in population with the CO2 increasing. With the graph, I don't know why it's getting so bright. There you go. With the decrease here, and we can see this simply with the graph. And with my hypothesis, we can definitely see that unless we do something about it, our polar bear our polar bear population is going to continue to drop, and eventually, I hypothesize in the next 10 or 20 years, we may not be able to see our polar bears anymore unless something is done. Unless we're able to fix the problem and really attack it at its core, we may not have polar bears or penguins or any Arctic animals of that sort in our future. Now, there's nothing to say about other animals that are being affected, but we can definitely see that these Arctic animals are at risk. Thank you for listening to my presentation. I hope you enjoyed.